Hi, I'm Ms. Vuong. Let's solve application questions that contain quadratic graphs. Example 1. A nozzle fires a stream of water from the center of a fountain whose pathway can be modeled by the equation h equals minus x squared plus 5x, where h represents the height of the stream of water and x represents the horizontal distance in meters from the center of the fountain. Part A, sketch the graph, and Part B, state the maximum height of the water. So first of all, we notice that it's a negative graph because the sign in front of x squared is negative. Next, to sketch the graph, we have to find the x-intercepts. To do so, we let h or y equals 0. So now we have 0 equals minus x, x minus 5, which means x equals 0 or x equals to 5. If you've forgotten how to do this, click on the little eye and it'll take you to a video to solve these. So let's sketch that, 0 and 5. Next, let's find the turning point. The turning point happens in between those two values. So 0 plus 5 divided by 2, which is 2.5. That's the x value of the turning point. And to find the y value of the turning point, we just have to sub that in. So sub that into the equation, minus 2.5, 2.5 minus 5, put that into the calculator and we get 6.25. So that's our turning point. Sketch that in. And we notice that we're on the right track because it's a negative graph and we can definitely draw a curve into that. And because we're measuring height, we don't have negative y values, so we have to get rid of those. Now we've sketched it. Let's look at the next part. State the maximum height of the water. So this is height, y value is height. So the maximum height is the turning point, or 6.25. So let's write that into our answer. The maximum height of the water is 6.25 meters. Example 2, last example for today. Sasha releases a little rocket from the edge of a bridge. The height of the rocket can be modeled by the equation h equals negative 5t squared plus 10t plus 15, where h is the height of the rocket above the water and t is the time in seconds. So be very careful, this time the t is time, not horizontal distance like example 1. Let's read the questions. Part A, what is the height of the rock at the time it is thrown? Part B, when does the rock hit the ocean? And Part C, when does it reach the maximum height? So let's start with the first one. What is the height of the rock? So looking for h at the time it is thrown. So at the time it is thrown means at t equals to 0. This is a very common question when x is 0 or t is 0. So let's plug that in. H is equal to, put all the zeros where t's are, sub that in. So h is equal to 15. The initial height of the rock is 15 meters from the water, or above the water. Part B, when does the rock hit the ocean? Hit the ocean means the height is 0. So notice the first question and the second question. You'll get these questions very often when we analyze quadratic equations. So subbing in h equals 0, we can see there's a highest common factor here of 5, or negative 5 we can take out. So negative 5, take that out, we have negative 5 times what is negative 5t squared? That's t squared. Negative 5 times what is 10t? That's negative 2t. And negative 5 times what is positive 15? That's negative 3. So now we have to factorize. We can think of numbers that multiply to give us negative 3 and add to be negative 2. Well, 3 times negative 1 gives us positive 2. So we have to move the negative sign to the other value. So negative 3 add 1 does give us negative 2. So let's bracket that off. So t is now equal to 3 and negative 1. And since t cannot be negative, we have to write since t is greater than 0, then t is equal to 3. And so the rock hits the ocean at t equals 3 seconds. Part C, when does it reach maximum height? We notice the equation is a negative graph, so it looks like that. So the maximum height happens at the turning point. Do note that when it's asking for when, we're looking for t. And when we're asking for what, we're looking for h. So little clues so that you can solve the question. So we're looking for t at the turning point. So to find t at the turning point, we're taking the middle of the two x-intercepts or t-intercepts. So that's the middle of 3 and minus 1. So we take 3 plus minus 1 divided by 2, which is 1. It reaches the maximum height at t equals 1 second. If it was asking for what is the maximum height, then we would have to sub that t in to find what h is. In summary, when we look at application types of questions, you might be asked for the y-intercept, but they might word it as the initial height value or the initial cost, something like that. And it might ask you for the x-intercepts by asking questions that read along the lines of when is the height 0 or when does it hit the ground. You might be asked the x value of the turning point. To find that out, you would average the x-intercept. And the question might read along the lines of what is the time when the minimum or the maximum occurs? In the previous example, that was a maximum type of question. In this graph, it will be a minimum type of question. You might also be asked for the y value of the turning point. The question might read along the lines of finding the maximum or the minimum amount or the height or the time, depending on what the y-axis is. Try these two examples again to see if you get to the same solutions. Thank you for watching, and I'll see you next time. Bye!